Okay, so a few things to keep in mind. Friday, you are having a test over Chapter 7. Yes, I realize I am not here to ask questions in class today. However, I will be here Wednesday morning to answer any questions that you have. What we're going to be looking at today is the start of Chapter 3. The first section is about solving linear systems of equations. We are going to be looking at what systems of equations are. These are our vocabulary terms for this section, which is 3.1. So we're looking at systems of linear equations, which are two equations, could possibly be more, we will eventually get there, with variables x and y that can be written in a system set. This is the set notation bracket. The solution of a system is an ordered pair that satisfies each equation. To say that a system is consistent, that means a system that has at least one solution. An inconsistent system is a system that has no solution. To say that a system is independent, it has to be consistent and has to have exactly one solution. To say that a system is dependent means that it is a consistent system that has an infinite number of solutions. So today, like I said, we are going to be solving these graphically. So if I have something like 4x plus 2y equals 4 and 2x minus 3y equals 10, well, what am I going to want to do? The first thing I'm going to want to do is actually graph that system of equations. So what's going to happen is I'm going to basically create an x and y intercept graph using these points. So I have my y-axis, I have my x-axis. Remember, those will always need labeled. Now for my first point, I've got 4x plus 2y equals 4. In order to graph that line, first thing I'm going to do is I'm going to set x equal to 0. So I'm going to have 4 times 0 plus 2y equals 4, which gives me 2y equals 4, which tells me that y equals 2. So my first point for this line is going to be at the point 0, 2. Now for the second point, I'm going to let y equal 0. If y equals 0, I'm going to have 4x plus 2 times 0 equals 4. That gives me that 4x equals 4, which tells me that x equals 1. So my next point is going to be at 1, 0. So graphing those 2 points here, what I'm going to have is I'm going to have a point at 0, 2 right here. I'm going to have a point at 1, 0. I'm going to get my handy dandy straight edge out, and remember, your graphs should have straight edges. Bare minimum, we gave you one with your student ID, and I'm going to play connect the dots right there. So this is the graph of 4x plus 2y equals 4. Now, to get the other graph, I'm going to have to solve that equation. Remember, I had the other equation was 2x minus 3y equals 10. So first thing I'm going to do is let x equals 0. So I have 0 times 2 minus 3y equals 10. So y is going to be negative 10 thirds. Then I'm going to let y equal 0. If y equals 0, I'm going to have 2x minus 3 times 0 equals 10. That gives me 2x equals 10. So x is going to equal 5. So I'm going to have to graph those two intercept points. So x equals 0, y is negative 10 thirds, so that's 3 1/3, so that's right here. And then if y equals 0, x is equal to 5. It's 2, 3, 4, 5. So that's here. And again, we're going to play connect the dots using a straight edge. Straight edges are critical on this assignment because you are solving them by graphing. Now the solution is where x marks the spot. It's right here. Now you're probably saying, okay, there has got to be an easy way that I can do this with my calculator. And yes, there is a way that you can do this with your calculator. You can put your system of equations into your calculator, but in order to do so, you have to get them into y equals form. So in this case, to put this first equation into y equals form, I'm going to take the 4 that's over here, minus the 4x, and divide it by the coefficient of y, which is 2. To get the second equation into y equals, I'm going to have 10 minus 2x, and I'm going to divide that by the coefficient in front of y, which is negative 3. Now I'm going to take and I'm going to put those in my y equals on my calculator. So, on my calculator here, my y equals, I'm going to have 4 minus 4x divided by 2. Yes, parentheses are important. And then I'm going to have 10 minus 2x divided by, remember the negative is down by the decimal, negative 3. And once I have those in my calculator, I am going to make sure I'm in my normal zoom, and I'm going to hit graph to graph them. So I've got 2 lines. They're not showing up super clear, so we're going to zoom in. And that is not working so well. So we can see there that they're crisscrossing. Now to find where they intersect, I'm going to do second trace. That gets me the calc menu. And you see this option right here that says intersect. We're going to choose that, and it says, okay, pick a graph. First curve, I'm going to hit enter. Second curve, I'm going to hit enter. So we've changed between the 2 lines. And it says a guess. If they only crisscross once, I can hit enter anywhere, and it will go straight to that point. And here it tells me that point is at 2, negative 2. So that is my solution to this set of equations. My solution is going to be 2, negative 2. Now you may be asking yourself, okay, well I can put this in my calculator. Do I ever have to graph this by hand? Yes, yes you do. Every single time that you graph it by hand, you check it with your calculator. Every time you graph it in the calculator, you still graph it by hand. Until we get a little bit more practice doing this, you will need to do this every single time. So, let's try another problem. So, let's say we have the set of 4x plus y equals negative 2 and negative 6x minus 3y equals 12. So this is our set of equations. So what can we do? Well, we can graph these. So, first equation, I'm going to have 4x plus y equals negative 2. If x equals 0, I'm going to have 0 plus y equals negative 2. Well, that just means y equals negative 2. So I'm going to have 0, negative 2 is one of my points on that graph. Then I'm going to set, okay, y equals 0. So I'm going to have 4x plus 0 equals negative 2. So that means x is going to equal negative 1/2. So another point on this graph is going to be negative 1/2, 0. Looking at the other equation, I'm going to have negative 6x minus 3y equals 12. I'm going to let x equals 0. At x equals 0, I'm going to have 0 minus 3y equals 12. So that means y is going to equal negative 4. I'm going to let y equal 0. So I'm going to have negative 6x minus 0 equals 12. So that means x is going to equal negative 2. So my points on this line are going to be 0, negative 4, and negative 2, 0. So let's set up the graph. We're going to graph it by hand, and we're going to estimate that solution. So here is my x-axis. My y-axis. Now I'm going to do something different. I'm going to let my x scale be 2. So that means this is going to be 1 unit. So if I do that, so what's going to happen? I have a negative 1/2 here. So I've got negative 1/2, 0 is 1 point here. And I've got 0, 2. And if I want to, I can make this also a 2 scale. So instead of 1 square, we're 2 squares. So I can play connect the dots. I've got 0, negative 2, and I've got negative 1/2, 0. And I can play connect the dots there. There's my first line. So this is going to be equation 1. My second one, I've got 0, negative 4. So that's going to be this point right here. And then I've got negative 2, 0. So this point right here. So let's see right there. Gonna play connect the dots. Okay, and we've got to figure out where these lines cross. Now, if I look up here, you're going, well, they don't really cross. But if I look towards the bottom of the graphs, where this is equation 2 and this is equation 1, they do cross. They meet right there at that point. That point, if we count over, that's 1 on the x-axis. And if we go down, that's 1, 2, 3, 4, 5, 6. So that's negative 6. That would be our solution point, where they crisscross. Now, if I wanted to check the solution by algebra, what I do is I take this point and I'm going to plug it back in to each of these two original equations and make sure that this condition is met, that this answer really is the answer. So if I want to talk about systems of equations and I want to talk about solutions, there are a few different ways we could talk about the number of solutions to an equation. If we have a graph such that the lines crisscross so that there is exactly one solution, we say that the lines intersect at one point. That should be an I there. This system is considered to be both consistent and independent. Now, X, that's Y. If we have a system where when you graph it, it looks like there is just exactly one line. That means the two lines are right over the top of each other. This is where it's handy to have that colored graphing calculator, because you can see only one color, and if you see the second color, you know the first color is underneath. This has an infinite number of solutions. So it has infinimany. We say that the lines coincide. They are on top of each other. Now this system is consistent, but it's dependent. Those lines are not independent of each other. They are dependent. And that takes us to the most interesting system of all. So in this system, if I have a system of lines, if these are parallel lines, so we say the lines are parallel, there is no solution. We say this system is inconsistent. So, what can we do with all of this information? Well, we could graph the system of equations. We could determine how many solutions there are, and we could classify that system. And when I say classify, I'm talking about, is it consistent? Is it inconsistent? Is it dependent? Is it independent? And you will have to make all of those classifications. So if I have something like 3x minus 2y equals -6, and -5x plus 4y equals 8, and I graphed those lines. So we're going to put those lines in our calculator here. So I've got to get them into y equals format. So to get this first one into y equals format, I'm going to have -6 minus 3x divided by -2. This next equation is going to be 8 minus a -5x divided by 4. So I'm going to have -6 minus 3x, not power of, divided by -2. And I'm going to have then, okay, my next one is going to be 8 minus a negative, so plus 5x divided by 4. And I'm going to graph that system of equations. So here's my first one right here, and my second one is right here. So they only cross at one point. So by them crossing at one point, so they have one solution, that means they are independent. And consistent. There are many other examples on this section in your book. Now, I'm sure by now you're wondering what the homework is. So your homework, which, yes, is due Wednesday. So the homework for 3.1 is going to be 3 through 36 multiples of 3. That's 3 through 36 multiples of 3. If you have any questions, send me an email.